off of the homework from yesterday. We had a few sections out of the small book on working with whole numbers. That's probably a lot of calculator work, but trying to interpret the problems is really the big skill there. Any problems you want me to go over that you weren't quite sure how to do them? Or well, I had mentioned every 3 or 4 hours of class there is a quiz. So if you're doing the Blackboard, there will be a quiz listed for today. The way I have been advised to do this, we'll see how it works. I'll show you here in just a second as I can get. Is when you get into Blackboard, and it's still in course information. You can see once you go into that week 1 folder, there's the normal links for each day with the homework and the link to the Blue Jeans recording. But then if you scroll down, there's also a quiz here. I'm actually going to move that up so it's before. Can't do it right now, I guess. There we go. So that it is before the link for today. That quiz is out there. You can link on that quiz and download it. Then when you're done, you can actually, this right here, you'll be able to link to that to upload it. You can see there's a submit thing. Just like doing an attach it to an email, when you click submit, it'll allow you to browse your computer and find that quiz that you've got downloaded and uploaded it. Like I said, if you have several options, you either print it off, complete it, scan it back in, or you can just download it to your computer, type in the answers, and do it that way. Or if you really have to, it's a little bit trickier. You can use your cell phone to scan it in, just take a picture of it when you're completed, and submit that picture of it. But doing it this way, I guess it allows me to make a lot more comments on it so that you can see, I can give you some more feedback on what you've done with it. So we'll give that a shot. That quiz is due. I think I have it set to be due by noon tomorrow. So if you have any problems with it, we can straighten them out in class tomorrow morning. So be aware of that. That quiz is out there for you to do between now and tomorrow. Okay, well, let's go ahead and we'll get started with our new material here. Yesterday we talked about those operations with numbers and all that. Today we want to look at what happens if we run into things like this. Where we have multiple numbers, not just two numbers being combined, and there's multiple operations to be performed there. There are a lot of different ways that could be interpreted. Some would just go left to right, which would make sense. That's how we read, is left to right, where you do the 17 minus 2 and then go from there. But that actually would not be correct. And each of the different ways that you could interpret doing that problem could potentially give you a different answer. And in math, we really like to have two people do the same problem and get the same answer every time. So in order to make sure that there is only one correct solution to that, in math we've defined something called the order of operations. Now, many people view the order of operations as a set of steps. That's not quite true. What it really is levels of priority. When there's more than one operation to do on a number, the higher priority has to happen first. Like the 6 here. The 6 has multiplication on one side of it and addition on the other side of it. Well, we need to look up to see which of those operations has a higher priority. And that's what would have to happen first to that 6. And there actually are We mentioned yesterday that there's more than one way to add, more than one way to subtract. There really is more than one way to interpret the order of operations. I'm going to show you the most common way today, but if we have some time, I may show you some of the other ways that it can be interpreted. So our highest level of priority, the things that have to happen or that we have to acknowledge at least before anything else, is something called enclosing symbols. Now, many of us have heard that when we've done order of operations before, is just parentheses. Well, parentheses is the main type, the most common type of enclosing symbol, but there are other enclosing symbols that we run into. Now, our second level of priority is actually one of our pairs of operations. We talked about pairs of operations like addition and subtraction go together, multiplication and division go together. Well, this pair is the exponents. And the pair of operations is actually powers and roots. Just like multiplication and division, one's going forward, the other's in reverse, the same thing there. Powers are going forward, roots are in reverse. Third level of priority then that would happen after exponents is the next pair of operations, multiplication, division. And finally, our lowest level of priority is addition and subtraction. Now, there are several pairs of operations that are missing here. Exponentials and logarithms, trig functions and their inverses, their reverse, their pairs. They go into this up in this area, depending on how they're grouped together. It's just when we do our basic order of operations, we only define these 4 levels of priority because those are the things that occur the most often. But there are other pairs of operations, and they do fit into these levels of priority. They have their place within these levels as well. When we run into them, we will talk about that and how they fit in. Let's bring this back to this original problem. The main way that the order of operations is interpreted is to look at the whole problem in general. Multiplication, looking at this, there are no enclosing symbols. There are no exponents, so multiplication is the highest level of priority. We have the 2 times 6. Now the way it works is we take that 2 times 6, we remove it, and we replace it with the result, which of course is 12. The rest of the problem gets rewritten exactly like it was. Now our next step then, there's no more multiplication and addition. We're down to the lowest level of priority. There is both addition and subtraction, so when that occurs, where we have 2 items in the same level of priority, a lot of background noise coming in on somebody's mic. I'm going to take a peek through to see if I can isolate it. There, we got it. If you're trying to talk and I don't appear to hear you, just wave your hand. I muted a couple of you to get rid of some background noise, so just be aware I won't be able to hear you. Just give me a wave and I'll see you and I'll unmute you. So anyway, we have both subtraction and addition here. They are the same level of priority, so we're going to work left to right. 17 minus 12 is 5. And then we have the 5 plus 8, which is 13. And that is the solution for that. Now, I said that the order of operations could be interpreted sometimes in different ways. We looked at the whole problem in general here and went about it that way. Another way the order of operations could be interpreted is to look at, just to pick a number and start with that number and work out from it. And it actually ends up giving pretty much the exact same process. But let's say we pick the 6 and work on the 6. We mentioned that before. Well, the 6 has two operations operating on it, the multiplication and the addition. Multiplication has higher priority, so we have to do that multiplication first. So 2 times 6 is 12. Well, the 6 is gone, so we can't work with the 6 anymore. The 12 is kind of where the 6 was, or the 6 has been replaced with the 12. If I want to keep focusing on it, I can, or I can pick a different number to work with. But with that 12, there's subtraction in front of it and addition after it. They both have the same level of priority. So if both operations have the same level of priority, we perform the one on the left. We check that 17 doesn't have anything else on the other side that's more urgent, so we can go ahead and combine. 17 minus 12 is 5. And then all that's left is the 5 plus 8, which is 13. So you can see we get the exact same answer. And if you look at each step, we combined the same thing in each step. It was just about how we went about deciding what was the next thing to combine that was a little different. But the whole process ends up looking the same. It's just how we approached it that was different. Well, let's look at a problem. That was a pretty simple order of operations problem. Let's look at one that's a little bit more difficult. Something like 17 plus 3 times 11 minus 2 times the square root of 25 plus 5 times 9 divided by 3 times 2 minus 2 squared plus 3 plus 4. So I know I put a lot in here. It looks like it's a lot more complicated, but it really isn't that bad. There's a lot more to pay attention to, but as long as we're careful and follow along our steps, our order of operations, it won't be any more difficult. A lot more writing, but that's about it. So our highest level of priority is enclosing symbols. Here we have multiple sets of parentheses. So as I said, we will go left to right. Going left to right, this is our first set of parentheses. Our first parenthesis. They come in sets, so we need to find where the other end of it is. Well, this one is facing the wrong way. That can't be the other end. This one here has to go with this button back here, so that can't be it. So the other end of it is actually all the way over here. So that is our first enclosing symbol going left to right is inside that blue box. Now inside there, order of operations still applies. So we have to look for other enclosing symbols. Now a square root symbol actually can be an enclosing symbol. Right now it is not because there's only one number inside of it. So it's not separating out part of the problem from the rest. But this parentheses here is definitely an enclosing symbol. So we're going to narrow our search now. We're going to work inside that green box now. Well, inside that parentheses, we still apply the order of operations. So we're looking through. There are no more enclosing symbols. There are no exponents. Multiplication and division, we have multiple operations. So we're going to work left to right. 9 divided by 3 is 3, so I replace that with a 3. Now this is actually where I see most of the mistakes made, is we have to rewrite the rest of the problem exactly how it was. Nothing else changed. What I do is I put a box or a circle around the two numbers I'm combining. I make sure they get replaced with the one number that's the result. Then I make sure everything that's outside of that box gets rewritten. Like I said, usually most of the mistakes I see on these, somebody wrote the rest of the problem down wrong after doing part of the calculation. So we're still working inside that parenthesis there. There's only one thing left to do, and that is the multiplication. 3 times 2, which is 6. So we replace the 3 times 2 with 6, and we rewrite the rest of that problem. Now, that parenthesis in the green box basically that we were working in is down to a single number in that parentheses. Anytime an enclosing symbol gets down to a single number, it's not working as an enclosing symbol anymore. So we can get rid of it if we want to. We can keep it if we want to as well, because parentheses have other meanings other than an enclosing symbol. Right now, it's not working as an enclosing symbol anymore. The only thing this parenthesis is signifying right now is actually the operation of multiplication. Anytime there's a number outside of parentheses, it's implying that number multiplies by what's inside the parentheses. So I could leave those parentheses in there to signify that multiplication, but it's often confusing to keep seeing that parentheses and not do anything with it. So it's usually simpler to remove that parentheses. We just have to make sure that we put in that multiplication symbol there so we don't lose that operation. So I'm going to rewrite this problem without the parentheses in it. Without that set of parentheses in it, I should specify. Because I'm done with it. I'm just putting in that multiplication so I don't need that parenthesis anymore. Now this is actually, I try to warn people against combining and doing 2 steps at once. This is actually the one spot where I probably would have combined. When I combined the 3 and the 2, and when I wrote this line here, I would have just taken the parentheses out there and put in the multiplication, rather than having to rewrite the whole problem again. We're going to have to rewrite it enough times before we're done. No use making extra work for us if we can avoid it. So now we're done with that parentheses. We're out to the bigger set of parentheses here that we started with, the blue box. Inside there are no other enclosing symbols. There is a couple of exponents. So working left to right, we will start with the root here. The square root of 25 is 5. So I replace that square root of 25 with 5. Now, it is an enclosing symbol, and it did have a number in front of it with no operation. So that is multiplication that has to be put in there. So I'm going to rewrite the rest of the problem. Here we go. And move on to the next exponent in there. We're still working inside that larger parentheses. Still doing exponents left to right. We have the power. 2 squared, which is 4. So let's rewrite the rest of that problem again. Next, inside that parentheses still, no more exponents, so we are down to multiplication and division. Go left to right. 2 times 5 will be 10. Now this is one spot where you could have done the 5 times 6 too, because they're disconnected. There's another lower priority operation in between them. But doesn't always work out that you can do multiple things in one step. So I try not to show it. If I were doing it myself, though, I probably would take that shortcut. If you're going to do that, just be careful. Make sure that you're not violating the order of operations. If this was multiplication or division between here, you wouldn't be able to do that. I keep it separate just to make sure I don't make a mistake when I'm doing the examples in class, at least. So now we still have one more multiplication, the 5 times 6, which is 30. Now inside that parentheses, we are down to just addition and subtraction, so we're going to work left to right. 11 minus 10 gives us 1. Still inside the parentheses, we have 1 plus 30 gives us 31. And finally, last thing we have is the 31 minus 4, which is 27. Now here I am going to combine a couple of things at once here. That parentheses is down to a single number, so I don't need the parentheses anymore. I have to check to see if that parentheses signifies anything else. And in this case, it does also represent multiplication there. That's 3 multiplying what's in the parentheses. I have to make sure I put that multiplication in there. Now looking at the problem in general, there is another set of parentheses to work on. That's the 3 plus 4 over here. So I'm going to perform that operation. 3 plus 4 is 7. Again, that parentheses is down to a single number, so I can take it out. When I look, I see that that parentheses is not signifying anything else. It's addition in front of it, so it's not showing multiplication, so I don't have to worry about putting in any additional operations when I remove it. So now there's no more enclosing symbols, no more exponents. There's multiplication, so I'll do that. 3 times 27 is 81. And now I'm down to addition and subtraction, so I'm going to go left to right. 17 plus 81 is 98. And finally, 98 plus 7, 105. Now, yes, that was a mouthful. That was a lot of steps to do. But you can see at each step, it wasn't a choice. It was simply doing what the order of operations tells us has to come next. Technically, we could have at every step went back and reevaluated the whole problem. But once we narrow it down to an enclosing symbol, we could stick to it. You know, like here, after we combined the 9 divided by 3, we could have gone back to the whole problem and evaluated again. Okay, well, let's narrow down our enclosing symbols. But we already knew we were focused in on that part of the problem. We finish that part of the problem, then we go back out and look at the bigger picture. Saves you a little bit of time from doing the complete analysis over again. Well, there are some other types of problems I want to make sure we get a chance to look at. Some that are lesser known and that we're not so sure of. The problem we just did up here is actually a very calculator-friendly problem. I could actually punch that problem into my calculator the way it is written there, as long as I'm careful not to miss anything. And the calculator will do it correctly. 17 plus 3, parentheses, 11 minus 2, square root of 25, plus 5, parentheses, 9 divided by 3, times 2, close parentheses, minus 2 squared, close parentheses, plus parentheses 3 plus 4. As long as I did everything correctly there, you'll notice it does spit out 105. It gives us that same answer. So the calculator does do order of operations correctly. You just have to enter the problem. Well, this problem was relatively easy to enter because it was linear. What I mean is it can be written all on one line like that. But not all of our problems are that friendly. We can run into a problem that looks like this. Something like 7 times 6 plus 72. We want 72 divided by 12 over 74 divided by 2 minus 5 squared. So in order to do this problem here, we first have to understand, what does this line across here mean? Most people say divide, and it does mean divide. It's one of the things it means. It's called a fraction bar, and it does mean divide, but it's also an enclosing symbol. It separates part of the problem from the rest of it. So what it means is we have to do everything on top, we have to do everything on bottom, and then we combine those with dividing them. So we'll start out with everything on top here. I'm going to rewrite that off to the side so I have room to work through it. So 7 times 6 plus 72 divided by 12. So there's no other enclosing symbols in that. No exponents. There is multiplication and division. So we're going to work left to right with the multiplication and division. 7 times 6 is 42. Well, we still have more multiplication and division. We have the 72 divided by 12, which gives us 6. And then we have 42 plus 6, which is 48. So the top part of that fraction comes out to 48. Now we work on bottom. On bottom, no enclosing symbols. We do have an exponent. 5 squared is 25. No more exponents, but we do have division. 74 divided by 2 is 37. And then, of course, we have 37 minus 25, which is 12. So the bottom part of that fraction comes out to 12. Now that we have completed everything on top and everything on bottom, now we can do that division. 48 divided by 12 gives us 4. Now, I make sure I always do at least one example like this, because here is a problem that would be very difficult to enter in the calculator. So if you are going to use the calculator on a problem like this, the way I would advise you do it is exactly how I did this here. Do the top separate, the bottom separate, write those numbers down and divide it. You can do the 7 times 6 plus 72 divided by 12. It'll give you that 48. And you can do the 74 divided by 2 minus 5 squared, and it'll spit out the 12. And then you just have to do the 48 divided by 12. If you were to try to enter this and the calculator is all one problem, it becomes a mess, because you have to put parentheses in there to replace the enclosing symbol. Most calculators don't do a fraction bar where you can put this in just as it appears here, with part of it on top and part of it on bottom. There are a couple of models of calculator that do that, but they're not worth the extra money that they cost. So I'd have to put in parentheses in order to account for the fact that that fraction bar is an enclosing symbol. So it gets to be very, very tricky to get those parentheses in there correctly. Another type of problem I want to look at. something like this. Now, when we look at this, of course, we see the exponent with the root, the square root there. But that square root in this case is also an enclosing symbol. It separates part of the problem from the rest. If there's only one number in there, it's just a root. But when there's multiple things inside of it, it becomes an enclosing symbol. So we have to do what's inside of that square root symbol first. Order of operations still applies. We have to do the multiplication before we do the addition. 9 times 7 is 63. Well, we still have the 1 plus 63 in there, giving us 64. Now, just like with parentheses or with the fraction bar, it's down to just one number inside that enclosing symbol, so we can get rid of the enclosing symbol. In this case, however, we don't just get rid of the symbol. Like in the fraction bar, we had to have it down to a single number on both top and bottom, and when we got rid of it, we had to divide. Well, here, when we get rid of the square root symbol, we have to do the square root. The square root of 64 is 8. Now, technically, the square root of 64 is both 8 and negative 8, but for our purposes, we're going to take the positive number. Now, just like with parentheses, when I take out that symbol, I have to make sure that it's not standing for representing something else. It is actually representing multiplication here, because there's the 3 in front of it with no operation there. So I have to make sure I put in that multiplication when I remove that square root symbol as well. 2 times 39 minus 3 times 8. Now again, back to our levels of priority. There are no more enclosing symbols, no more exponents. So we're going to do multiplication and division left to right. 2 times 39 is 78. Then we have 3 times 8, which is 24. All that's left is subtraction. So we'll go ahead and do that. 78 minus 24 is 54. So there's our solution. Because there's a quiz today, I want to give you a little extra work time so that you have time to get a good share of your homework done so that you have time to put onto that quiz. And there's actually 2 different assignments today. The first part comes out of the big book, page 26. Well, I believe it's exercise 1-11. And in that, I want you to do problems 7 through 39. The odd numbered problems again. Remember, the solutions to the odd numbered problems, even in the big book, those are in back so you can check those as you go. Now, just like I said yesterday, the first couple here may be pretty simple. So if you're struggling with them, you may want to do those to help practice and get good at it. But if they seem easy to you, please feel free to skip towards the end and do the last 4 or 5 problems that are more difficult or more complex. But make sure you do a few of those to make sure you have them down. And also in the little book, it's Unit 5, also the odd numbered problems. And those solutions are still in the back of the book as well. And then, again, sometime today, make sure you get that quiz 1 from Blackboard. Complete it and submit it in Blackboard. I was going to have everybody email them to me, but it was pointed out to me that can be a logistical nightmare if you have 7 classes emailing you quizzes trying to keep them straight. So we'll use Blackboard to return them to me. If you have any issues with it, let me know and I'll help you out. Okay, usually, like I said, I will give you anywhere from 5 to 15 minutes to get started on your homework. So we have about 13 minutes here. I'll let you guys get started on your homework here. I probably won't keep you for the full 13 minutes. We'll work for a little while. If there's no questions that come up, I'll let you go a little bit early so you have time to work on that, try to get that quiz downloaded if you need to. I'm going to end the recording here for you. Anybody have any questions? Okay, we'll give you some work time here then.